Hi everybody! Today we are going to be taking a look at multiple regression, a statistical technique that is used to predict the value of a dependent variable based on two or more independent variables. I will show, before going to show my model, I will show my data in here. Okay, we'll predict the price of the house. This column is my dependent variable. Predict the price of house according to my independent variables. What are they? Advertising number and the number of rooms, the number of bathrooms, meter square, and the age of the building. Okay, what are these columns? I'll explain. What did I do in here? Standardization. I use the standardized method because when you look at the data in here, these numbers, there are a huge gap between the numbers. This is big number and this is small number. So standardization is a common pre-processing step in machine learning, and it involves rescaling the features of a dataset so that they have the properties of a standard normal distribution. So this process is also known as Z-score normalization, but we need to do standardization to equalize the scale, helps convergence. Okay. Now, first of all, we import our libraries. Okay. We are, after importing the libraries, we'll load the data from an Excel file and exploring the data. Okay, what is my size of data and the shape of the data? Okay, that. For example, in here, it shows that we have 91 data and there is no null value correlation. Correlation analysis is a statistical method that is used to measure the strength and direction of the relationship between two variables. Data preparation will now separate the data into features and labels. So, the 11th column is my target variable, and these are my independent variables. So, these are my independent variables, and this 11th column, if you count start from 0, 11th column, the price of house is my target variable. So, okay. And splitting the data. We'll now split the data into a training set and a testing set. The training set will be used to train the model, and the testing set will be used to evaluate the performance of the model. Okay. And building the model. We split in here, and we build the model in here, and we fit our linear regression in here. We'll now build a multiple regression model using the scikit-learn library. Okay, we are interpreting the coefficients, so we can see our coefficients. So you can see that x1, the x1 feature has the biggest coefficient. Okay. Visualizing the relationship, we'll now create a scatter plot to visualize the relationship between the price of the house and the feature. Predicting the price. So okay, now this is not. Okay, we are now giving our x-test data. In here we separate our data and 30% of the data goes to x-test, and in here we find the predictions, the results, the predictions, price of the house in here for the test data. Now we'll evaluate the performance of the model using the mean square error and the root mean square error. I don't explain them in here. I assume you already know these concepts. Okay, mean square error, 38%. I think it's good. And this shows statistical explanation, t-value and p-value. You can also look at them. And now we are using standard scalar. Okay, regression predict fitter reach regression model. We are using now reach regression model and lasso regression model. After that, we'll look at the which one is best. Okay, sorry. Okay, almost same, but reach regression model has the lowest score for RMSE. I think it's a good exercise for today. Yeah.